Welcome to Lecture 9. This is the last lecture in Unit 3, so let's get straight into it. Okay, so originally I was going to do a brief overview of fire weather, but then I went back through the MED and the comment modules, and I found several things on fire weather that I just can't reproduce. There's just no way I can make anything even close to in depth as the modules they have on fire weather. All right, so I figured I would use this as an opportunity to show you where to get these modules, where to get these fire weather modules, and show it to you now because I really don't know how much longer they're going to be free. I mean, they could be free for another year, 5 years, or maybe it'll become a pay site sooner. All right. There's an incredible amount of information about more weather topics than you can imagine. So, not just fire weather, but a lot of the Western weather things we've talked about, and all sorts of weather topics, and a lot of them you never even probably even thought about. All right. There's hundreds and hundreds of modules out there for you to look at. So, I'm going to show you the site. I have the address up here or the link here for you to go. It's a free site. You make an account. You watch whatever modules you want. A lot of them have quizzes that go along with it. It's just to help you see how much you understand and how much you really retained. So I'm going to show you that, and then we'll talk a little bit more here. And then since I didn't go into fire weather as much, I added a 7-day forecast kind of mini lecture. This will definitely be the shortest lecture of Unit 3, especially since the Lecture 7 and Lecture 8 were definitely longer. All right, so let me show you this here. When you go to MED here, so here's med.ucar.edu. You'll get the home page. You'll have the sign up button here. Just go ahead and click on that. Sign up. Now, I will say this. If you do the quizzes, they ask for an email. Do not put my email down, all right? Or else I'm going to get hundreds and hundreds of emails. Do not do that, okay? Just sign up. You don't have to put anybody's email to send any results to. I say that again. Do not put my email. If you put my email on there, I'm going to contact you and tell you to go in there and take it out, all right? Not to be that guy, but I don't need hundreds and hundreds of emails coming my way, all right? So it gives you that option to put your instructor's email in it. Do not do that, okay? But it's easy to sign up. You make your name and password, and then once you do that, you have access to the site, and there's all sorts of just amazing things that you can look at. All right, so let's switch back over. I'll show you. I'm already logged in here, so I'll expand that out. When you go under education and training, there's all sorts of different things you can look at. All right, one thing too before I add, you see this button here? You see this donate button? That is something I've noticed recently. They're obviously seeking donations to keep this a free site, and that's why I kind of wanted to stress that I don't know how much longer it will be free. It could be free for another year, and it may not be free for another couple months. I just don't know. But use this to your advantage. Again, I'm not going to force you to do anything with this, but I just wanted to show it to you so you knew it was available to you and that there's a lot of great information there for you. So if you go under education and training, there'll be this topics button. And look at all this stuff. You got aviation weather, climate, coastal weather, convective weather, emergency management, environment and society, fire weather, fog, geospatial, hydrology, mesoscale, mountain meteorology, numerical, NWP, oceanography, QPF, radar, satellite, space. I mean, there's all sorts of stuff. Like, let me just click on one. Let's go with, I don't know, convective weather. I'll click on that. It may take a second to load. But you'll get all sorts of modules and different things that are available to you, all right? So just on convective weather, they have 47 different modules, all right? So, obviously you don't have to watch all of them, but maybe there's some of them that are of interest to you that you would like to learn more about, okay? So definitely check this out. If you love weather and you just want to continue to get better, this is a great tool to use. And keep in mind, of course, this is a great program, and we have a lot of great teachers, and we're all trying to teach you as much as we can, but we can't teach you everything. And a lot of it you're going to learn through experience, through the job, of course. But when you finish your education, you're just getting started. All right. I mean, I learned way more after I graduated than I did during school. All right. And a lot of it is just passion. What I always tell people, there's plenty of people smarter than me, but I feel like I try to work as hard as I possibly can. I try to outwork people. All right. That's one thing I try to pride myself on. So we have a lot of different things to pick from. Obviously, for what we're looking for, here's fire weather. I already have that clicked on here, and this is the course that I recommend. There's plenty of other different modules on fire weather you can look at, but I think this course is fantastic. It's called S290. It's the intermediate wildland fire behavior course. And there's a lot, all right. It starts with the introduction and it ends with takeaways, and there's 12 units. And if you decide to go through the whole class, it's gonna take you on average about 17 hours to complete it. All right, so it's a lot of effort. But I'm not making you do it. All right, so don't worry. I'm not gonna make you go through 17 hours of modules. But if you're really interested in fire weather, take the time and go through it. It's only gonna make you a better forecaster. And it's only gonna help you. If fire weather is not your thing, find another module or another topic you like and spend some time and try to get better at that. All right. So just wanted to show you that this is available. It is a free site, and I hope you guys do take advantage of it. All right. I'll switch back over here. All right, so I introduced you to common modules, MedED. Again, it may not be free much longer. There's so much information. It's just mind-boggling what they have on there. For this takeaway on the fire weather, I would go in fire weather, and it's the S290 units 1 through 12. It's an amazing series, which I can't even come close to duplicating, so I'm not even going to try. But it's there for you. Depending on your speed, it's going to probably take about 17 hours. It's not required, but I highly recommend it. All right. Obviously, I'm not going to require 17 hours of material. All right. And you don't have to do it all in one day. Maybe every day, just watch. You know what you could do, and this is something I did for a long time. Every day, watch one module. And some of them are 30 minutes, and some of them are a couple hours. All right. And if you did one a day, even 4 or 5 days a week, think how much you would learn within 6 months. You would learn an incredible amount of information. All right. All right, so I broke down the different units and how long each one is. It's going to take between 14 and a half and 19 and a half hours, so 17-hour average. You see some that are shorter and some are longer. A couple of them are 2 to 3 hours, 3 to 4 hours, and some of them are only 15 to 30 minutes. All right, so highly recommend it. Not going to force you, not going to test you on it or anything like that. But it's there. Now the site. There's a lot of great information. There's a lot of great topics. So it's there for you to use, and I hope you do. All right. So what I decided to add was a 7-day forecast. Since I'm not going to go super in depth on fire weather because the modules are just so incredibly good. There's no way I can compare to that. I can't make a 17-hour course, but I'm going to give you some tips on a 7-day forecast since we did do long-range forecasting, and I will keep this fairly short. All right, so you already have the tools to do this, all right? I see a lot of students ask me, like, well, I can't do a 7-day. I don't know how to do a 7-day, and I'm sure plenty of you in the broadcast world are doing them all the time, all right? So this is something that you're used to. But you have all the tools. The tools are there, all right? It's going to take time to get better at it and perfect it, but you have the starting point. You have the foundation now to at least get started, okay? Everything is there for you. You just have to practice and expand from it, all right? So again, one of the best things is you got to follow the weather every single day. I mean, if you don't follow the weather every single day, it's not that you can't do it. You can do it blind, but it's going to be far more accurate and easier the more you understand the pattern. When I would make my students do in-class forecasts, I could easily tell the students that are looking at the weather every single day versus the ones that weren't, because the ones that are looking at the weather every day, they knew exactly where to start because they've been looking at it every single day. They knew the biases, they knew the trends, they knew what was going on. They didn't have to sit there and read 15 different things to even get a starting point, right? So if you follow the weather every single day, and maybe for some of you just don't want to follow it every single day, I fully understand that, but at least try to follow it 5-6 days a week. If you took a day off every week, that's fine, no worries. But the more you follow it, the better. And as you've seen by now, pattern recognition is key. Okay, and as much as I wish I could tell you it's always going to be the same all the time, it depends on the time of the year. Okay, look how we ended the long range forecasting, right? We looked at the Southeast US, looking at things like the SOI, the NAO, the AO, the EPO, the PNA, but we're looking specifically for the winter time. That was the Southeast US during the winter time, okay? The same pattern in the winter can mean something entirely different in the summer. And you're just going to get better with that with experience. The wavelengths change, thinking back to Rossby waves. Things aren't always going to be the same all the time. A great example of that is the negative NAO. The negative NAO in the winter, we talked about this with the Southeast US, does what? It caused blocking in Greenland and caused troughs to dig down into the Southeast US, Eastern US, causing cold Arctic outbreaks and storminess, right? Well, why are those troughs able to dig so far south? Because you have a much more long wave pattern in the wintertime. But does that pattern stay the same in the summertime? No. The wavelengths change. They shorten, all right? And actually, the negative NAO in the summertime leads to hotter conditions, especially in New England and the eastern U.S., because that ridge expands and it just continues to push into the eastern U.S. and it causes a lot of, more benign weather, but hot, sticky, nasty weather, right? So that's just one example where winter is a very different result than summer, okay? So not only when you practice with this, you're going to have to get better at practicing at it at different times of the year, all right? It's not always going to be the same in the winter versus the summer, all right? Same thing with the biases with the models. They may be more pronounced in an El Nino season versus a La Nina, or in a cold PDO versus a warm ANO. The only way to really figure that stuff out is to take your time and to practice, and it takes years. I mean, it took me many, many years to feel comfortable with this. And still to this day, I don't know near everything, not even close. I mean, I'm trying to give you as much information as I can. I'm doing my best to basically teach you most everything I know the best I can. But in fairness, as good as I am at this, I still have a long ways to go. Okay. Um, I will never be an expert in this. People always call me an expert, but how am I an expert if I get maybe 67% to 70% right? That's not being an expert, okay? Yeah, maybe I know more than a lot of people, but I'm not an expert, all right? And I think when you keep that mindset and you stay humble, it just allows you to drive you to get better. And I like it, man. I personally like being wrong sometimes, and I personally enjoy the challenge because that's something I really love about weather and forecasting, that it's really, really difficult. And for me, I feel like that's where I can use my hard work and passion to kind of set myself apart. Okay. And in the end, again, you're just trying to be less wrong than your competition or the forecast model. Never going to be perfect. No such thing as a perfect forecast, but you can be less wrong than most everyone else. All right, so first, what are the models saying? And we've talked about the models in detail, and we've talked about the difference between the operational and the control run and the ensemble and the perturbations with the ensemble, and we've talked about the MOS, and we talked about different models, how, it's not just a GFS, there's a European, the Canadian, the Japanese, the UK Met, there's more, all right? So let's just, on this long range, this 7 day, I did it on a Wednesday. So I was focusing on Thursday through Wednesday, all right? So a 7 day period, all right? So, I try to keep it simple as I can. I was looking at GFS temperatures, operational. I was looking at GFS ensemble temperatures, both the control versus the perturbations. Again, Thursday through Wednesday, I was looking at the GFS long range MOS temperatures. So I was comparing those. I was comparing it to the Euro ensembles. I was adding other things, all right? Keep adding more and more as you practice. Maybe at first, just stick to the GFS and the Euro, and maybe throw in, I don't know, the Canadian or whatever. Just everyone's going to start at a different. Everyone's going to have a different starting point. All right, so maybe start with just a few models at first, and just keep adding more as you practice. It'll get easier. It's just like anything. Like when I first started writing weather blogs, it'd take me hours to write them. Now I can do it in 30 minutes, just because you get used to it. You get better at it the more you practice, right? Also, it's not just the models. What are the teleconnections saying? The pattern recognition. If you can't even get the trough and ridge right, you're not going to get the temperatures right, all right? So you got to get the pattern. So what's the NAO saying? What's the AO saying? The PNA, SOI, MJO. EPO, Japan Trough Ridge Teleconnection. We talked about that. What are the temps running in Canada? You remember when I showed you the Canadian website and we looked at the standard deviations in Canada, whether it's above normal or below normal? That's something to look at. Moisture connections. Do we have a tropical influence? Do we have moisture coming out of the Gulf? Do we have some sort of tropical cyclone that's feeding the moisture? I mean, those things are important. Are the water temps running above normal? Are they running below normal? These all play into it. And not to complex it even more, again, depends on the time of the year. NAO in the winter is different than the NAO in the summer. Okay, and again, that's just going to take time and practice. All right, so here's just a quick practice scenario, okay? And I was pretending it was just for Starkville, Mississippi, okay? So here's the GFS. Here's the GFS ensemble mean. Here's the GFS MOS. Here's the Euro. Here's the Euro ensemble, okay? And then I just put the NAO, AO, SOI, Japan, Trough Ridge, Canadian, okay? So let's just kind of break this down, all right? So at the beginning part of the scenario, and again, this is just purely hypothetical, but it'll make sense hopefully, is let's look at the differences. So at first, there's really not much of a difference, right? So if you're going with consensus and you felt like the models had a good handle, it's not too difficult at the beginning part of the 7-day. Where it gets difficult is later on, all right? So the GFS has a much different result on Monday, Tuesday, and Wednesday than the European does, all right? So let's just focus on the GFS versus European. The GFS on Monday and Tuesday are going lower to mid 90s. And then by Wednesday, it does cool off a little bit with a little bit of light rain. Okay. The ensemble mean is not quite as warm as the operational, but it's on that same general trend. Now, why would it probably not be the same as the operational? Well, it's a mean. It's a average of multiple perturbations, right? Whereas operational is one run. And in theory, this is the best model physics and initial conditions and the best power, right? The best computer power. So in theory, this should produce the best outcome, right? But you want to see if the ensembles are somewhat in agreement. And even though it's not going to be perfect, that is decent agreement, especially when you're looking at a mean that far out, okay? And even the MOS, while the MOS wants to do what? Trend to climatology, it is trending with that more warmer pattern, right? The trough comes through, but it's a weaker trough with light rain. Now let's compare that to the Euro, right? Again, at the beginning, not a huge difference, but again, in that Monday, especially in the Sunday, but Monday, Tuesday, Wednesday, look at those differences. Look how much cooler and a much deeper, more pronounced trough came through with heavier rain. So what do I go with? Do I go with the warmer GFS solution, or do I go with the colder, heavier rain, more pronounced trough Euro solution? Well, now this is where the pattern recognition comes in. If you've been following the GFS and the European every single day, and the GFS has continuously been overestimating over and over and over, well, it doesn't guarantee for sure it's going to keep doing that, but it's something you want to keep in mind. Sometimes the trend is your friend on this. Not always, but sometimes it can be. What about the Euro? What if the Euro's been nailing it? It's been seeing these troughs have been digging in stronger. That it's been cooler. Then yeah, maybe I would give more credence to that. But still, even though I've been following it and I've been seeing the trends, I want to look at the teleconnections. All right, and it depends on the time of year, right? So obviously a negative NAO in the wintertime would lead to a colder pattern for us in Starkville in the east. But in the summertime, a negative NAO would do what? Warmer pattern, especially in the east and New England, right? So it would depend, all right? So actually in the summertime, if I saw more of the positive NAO, and again, the NAO is stronger in the wintertime. We talked about that. But that's something I would want to consider. SOI, I'd want to know if we're more in meridional flow, if we're more in a zonal pattern. AO, yeah, I would look at it. This is more pronounced in the wintertime as well because troughs are really not going to dig near as deep into the southern U.S., but I'd still look at it. Japan Trough Ridge, I'd definitely look at that. If Japan is currently have a massive trough over them, and 6 to 10 days later, it's about in that time frame, 6-7 days right here. I'm looking at Starkville or looking at the eastern U.S. and I notice a massive trough over Japan, but one model showing a ridge and one showing a trough. I'm probably going to lean more towards the trough. Okay, so another thing to look at. Canada, especially in the wintertime, if the temps are running below normal, then maybe the models are not even going cold enough if you have a strong enough trough, all right? So there's just so many different things you can add to this, all right? One piece of advice on this is, let's say you look at the teleconnections and you feel confident the pattern shows a deeper trough and a colder pattern. All right, cool. I'm going colder, right? But this is where kind of, I don't want to call it a game, but this is where you gotta hedge your bet a little bit, all right? I have confidence. I believe in my abilities. All right. I'm going to go with what I think. And if I'm going down on a forecast, I'm going down on my forecast. All right. However, sometimes you can get a little too aggressive. All right. So let's say a lot of people are going with the GFS. They're going, 95 on Tuesday with light rain on Wednesday and cooling things off a little bit, right? Let's say you're like, all right, I'm going with the euro. I'm gonna go with these lowest temps. I'm gonna go 85 on Tuesday, right? The thing with that is, what if it's 90? Okay, and even though you were on the right track with cooler temp, now you're in between the people that were just going with the GFS, right? And especially in the longer range, what I would do is, all right, let's say I was thinking the Euros, right? I probably wouldn't go all the way to 85. I'd probably be more like 87, 88, right? Especially if normal temps that time of year were near 94. I know that that's still fairly significantly cooler, and this is just more of a benign example. Obviously, this would be much more pronounced in the wintertime with a deep trough. You could have 20, 30 degree differences between models, especially if you have fresh snowpack on the ground. But that's where you kind of want to hedge it a little bit. So I'd maybe go 87, 88, at least, on day one of a 7. And then as you get closer and you think it's going to be 85, you can adjust it down a little bit. But the difference is this. You start at 87, 88, and even if it ends up at 85, okay, you adjusted a couple degrees more down, but you're still beat everyone else that put 93, 94 and they had adjusted all the way down to 85, right? Whereas if you did put, 85 or 84 and ends up being 89 or 90, even though you were on the right track with a cooler solution, you ended up being just as wrong as everyone else, right? So that's kind of where, if you want to call it a game, that's where the game part comes in. That's what I always did in the forecast contest. Why did I win national titles, or why did we win national titles at Mississippi State? It's because many times in that scenario, or even in a daily 24-hour scenario, I would think to myself, well, everyone else is probably going to go this. And even though I think it's going to be even more aggressive, I'd rather at least pick up 2 or 3 degrees every day on someone than end up breaking even because I was too aggressive, all right? Now, there are times when you should go aggressive, all right? There are times when you feel confident, you really feel like you have the pattern down, then yeah, go aggressive. But in general, you don't want to do that all the time. It can backfire on you. All right, so again, you have the tools to do this. It's just going to take time, but I promise it'll get easier, all right? When I first started, I was not good at this, all right? It takes time, all right? When I first got to Mississippi State, I was 19 years old. I didn't even know barely what a weather model was, all right? It takes time, all right? So start with a few models and ensembles and teleconnections and just keep adding more as you feel comfortable, all right? And with time, you'll get better. You want to believe in your abilities and you want to believe in yourself, but you have to be careful about being too aggressive, right? Don't get too arrogant or too cocky. I've done it before where you're on a run, you're getting every forecast right. You're like, man, I got this. And then you go too aggressive and you get absolutely destroyed, all right? So, just keep in mind you're going to be humbled, all right? And you're not always going to win, all right? This is not if you want to call it a sport where you can win all the time, all right? You're going to lose. You know what I always say when I'm storm chasing, and forecasting is not to that level, but I always say when I storm chase, I'm like, you win some, you lose most, all right? But when you win in storm chasing, you see some amazing stuff. I wouldn't quite say that with forecasting, but you're going to lose a lot, all right? So just be realistic about that. You have to realize you can't nail the forecast in the long range, but you can definitely beat your competition in the weather models using sound pattern recognition. That is so important. Where's the trough? Where's the ridge? What does the teleconnection tell me? If the GFS is telling me it's going to be above normal with the ridge, but all the teleconnections are saying it's going to have a trough, then I have a problem going with the warm ridge. And where it really gets easier is if the operational GFS, remember when I showed you the Starkville example where the operational GFS was not forecasting much snow at all, but the ensemble was? That's where it can be more easy, where you're like, well, why is the operational GFS showing such warm temperatures when the ensembles are showing cold temperatures. The MOS is showing cold temperatures, and all the teleconnections say cold temperatures. All right, so sometimes a little bit easier, sometimes it's more 50-50 split, and that's where the experience and really digging into it is going to help you. All right, and something that I've always said, I guess if I'm not trying to quote myself, but this is something I always said before: is forecasting is an art which is only perfected by experience. Now I put perfected, kind of quoted a little bit. Obviously, nothing's perfected, but if you're trying to achieve being the best you can, the only way you can do that is by practicing and putting the effort into it and doing it over and over and over and over and over. And trust me, I know it's tough. Like, I was really glad to rebuild this class and do everything, but it's a lot of work. It takes hundreds and hundreds of hours to do this, right? So it's hard for me to do a lot of the forecasting stuff that I normally would because I have, things I have to do. I mean, I work, right? So I know plenty of you have kids and families and you're working hard. So I fully understand that you probably don't have 4 or 5 hours to dedicate to this. All right, I used to be able to do that, but now it's hard. All right, I wish I had more time, but life gets in the way. But just do what you can. Even if you did 30 minutes to an hour a day, it would really pay off. Just like the modules, if you just did one or two. Even if you did 2 or 3 a week, think how much you would learn, right? So just do your best. Again, it's an art. There's no exact way to do it. I'm teaching you how I do it, but I don't have all the answers, and there's other people that may do it a different way, and we can come to the same conclusion, all right? So it's only going to get perfected by practice, by experience, okay? All right, well, I hope this was useful. I try to keep it more on the short side, especially since lecture 7 and 8 were longer. I really hope you do explore with the comment modules and MedED because there's some fantastic stuff there. I hope this was a little helpful with the 7-day, and again, you can apply this to 14 days or even longer, a seasonal forecast, right? But maybe I think starting with 7 days is pretty good. If you start getting good at 7-day, you're doing better than most. All right, so hopefully you found this useful. I hope you got something out of it. And I'll be back with the start of Unit 4 and Lecture 10.